Once again, the next video which I am going to present to you is the demonstration of how to find the zero error of a given instrument. It may be an ammeter or it may be a voltmeter. Now the thing is that why should we need to find the zero error? Because students, if there is an error in the scale, then the reading, the observation you are recording is not the correct one. The observed reading is not the actual reading of the current if the ammeter is having zero error, and the actual reading of potential difference is not the exact voltage or potential difference if there is a zero error in the voltmeter. Now the thing comes in our mind is how to know whether a given device is correct, it doesn't have a zero error, or it does have a zero error. For that, you need to look these two devices. So my dear students, you can easily see that in this ammeter which is on my right hand side, the pointer is coinciding with the 0. But in this case, the pointer is not coinciding with 0. Actually, it is coinciding with the 7th division on the scale. Now, it means this one doesn't have a zero error, but this has a zero error. Now, if you do not have a correct ammeter, you have only this ammeter with a zero error. Now, what will you do? So, there is no problem. You can find the zero error and you can, remove the error from your actual reading by using the formula that actual reading is equal to observed reading minus zero error. Now here one thing more is to be taken into account or consideration, that is zero error can be positive or negative. Okay. Now how to find that whether the zero error is positive or the zero error is negative? So again we come and look into this device. Now you can see the pointer is above the 0, right? So you keep in mind, if the pointer of a device is above the 0 error is positive. And if the pointer is below the 0 error is negative. Okay. Now, let us look at this device. It is having 10 small divisions equal to 1 ampere. So, first of all, I calculated the least count. 10 small divisions is equal to 1 ampere. 1 small division is equal to 1 by 10, that is 0.1 ampere. That is, the least count is equal to 0.1 ampere. Okay. Now, how to find the zero error? Zero error of this particular instrument will be the number of divisions with which the pointer is coinciding multiplied by the least count. So, the zero error is 0.7 ampere. Okay. Now, let us say that when you use this ammeter in a given circuit for taking the reading, and your actual reading you have to find, but your observed reading is equal to 2 amperes. So actual reading will be 2 amperes minus positive zero error. Okay, so you will subtract 0.7 and then your answer will be that actual reading is 1.3 ampere. Right? So in this way you have to find the zero error of an ammeter, zero error of a voltmeter before you start an experiment. And for finding the zero error, you should know how to find the least count. So least count of ammeter, as I told you, either you can use the formula that number of small divisions, or the formula is range of ammeter divided by the number of divisions. Similarly, least count of a voltmeter can also be found in the same way. That is range of voltmeter, that is VR, number of divisions, that is Vn, and then least count will be VR upon Vn. Right? Okay. Ma'am, please give me a voltmeter. Just a second, students. I want to actually show that voltmeter and its scale so that the things are clear to you. Thank you, ma'am. Now you see this voltmeter, its range is 3 volts, okay? But number of 10 small divisions is equal to 0.5 volts. So, either you find like this, that least count is equal to 3 volts, 1, 2, 3, 4, 5 and 6, 60 small divisions, right? So 3 by 60, so it is 0.05 volts, okay? But if you don't, remember the formula, you can simply say like this, that 10 small divisions is equal to 0.5 volts, then 1 small division is equal to 0.5 upon 10, and again the answer will become same, 0.05 volts. Okay, now this particular voltmeter, does it have a zero error? No, there is no zero error, as the pointer is coinciding with 0. Thank you so much. Stay blessed.